Okay, looking at our do now problem, we have kind of really two things going on here, one in review and then one some preparation for today's lesson. So looking at this first problem, we're asked to find the measure of angle HAB. So looking at this, angle HAB here includes one of these that has an x, so we're going to have to find the value of x first. In order to do that, we're going to fill in as much as we can here. What I can see when I look at this is that we are missing these two angles. There's actually a couple different ways we can go about doing this. I can actually find out the value of this angle by thinking about this as a straight line. So we would have 90, 20, and that would be, this is a total of 110. And that would leave me with 70 here for that straight line and 70 here. And then we can set up the equation using that straight line moving this direction. So I'll go ahead and do it that way. That is not necessarily the only way we could have done it. I'll show you another way here in a second, but let's start with this way. My equation would be 70 plus 2x plus 3x is equal to 180. So 70 plus 5x is equal to 180. Add the negative 70 to both sides. That gives me 5x is equal to 110. Divide both sides by 5. That gives me x is equal to 22. Now I need to find the angle of HAB. That would be 3 times x, which would be 66. Remember I said there was another way to do this. We can actually think about, we have two straight lines here that are intersecting. So we know that they are going to be vertical angles here. This one we put together, we said was 110. So that means 3x plus 2x is equal to 110. And that's actually what we can see when we simplified it. 3x plus 2x is equal to 110. 5x plus 1, or 5x is equal to 110. That's the same thing that we had in that step there. So there are two different ways that we can really do this. One required us to figure out that this was 70. The other used vertical angles to basically get the same idea. So again, two different ways to go about doing that problem. As we look over here, we're using the same diagram to the left. What is the measure of angle CAB? Angle CAB over here, we're told is 2x, which means that we already know what x is. 2 times 22 is going to be 44. A little bit of review for today. Which inequality statement below? Which inequality statements below are true? We're going to select all that apply. So we're looking for the ones that are true. This one says negative 3 is greater than 2. That's not true. If we think about number line, all the numbers that are greater are this direction, and negative 3 would be here, and positive 2 would be over here. So this is not greater. Negative 5 is greater than negative 2. Once again, negative 5 would be over here. Negative 2 would be over here. So this is not true. Negative 4 is less than or equal to. So remember, the symbol means less than or equal to. So they are equal, so this one would be good. 4 is less than or equal to 6. That's true. 6 is less than 6. So 6 is not less than 6. It's equal to 6. We don't have the or equal to symbol here. So that one's no good. And 6 is less than negative 6. That's not going to be true. 6 is greater than negative 6. Alright, we're going to need that information about how to use inequality symbols moving into today's lesson as we switch tracks from our geometry. And today's aim, Kipsters will be able to justify the properties of inequality. Justify the properties of inequalities. We're going to definitely see what that means. That might seem a little confusing now because a little vague, but we'll see what that looks like as we start to get into our work. Justify the properties of inequalities. All right, preserve the inequality symbol. So we're looking at some quick definitions here because you can see in some of these tables that we're going to be filling out, we're looking to see if the inequality symbol is preserved or reversed. So preserved means that if we change something, if there's a change, if a change occurs to an inequality, the inequality symbol is still true. Is still true. So we see an example of this down here in our first table. They've added 2 to each side of this inequality. It started as a less than sign, and as they add 2 to each side of this, we still get that -1 is less than 7. So that means the inequality symbol is preserved regardless of whether that's changed or not. Now, reverses is going to be the opposite if a change occurs. The inequality must be reversed. Must be reversed. Just as an example, if we had the inequality 0 is less than 1, and I change the inequality by adding 3 to this side, it would become 3 and 1. Now we would have to make this statement true. We would have to turn it around. So this would reverse the inequality symbol. All right, so that's the definition information that we need going into this lesson. What you're going to be doing is you're actually going to be picking some kind of random numbers and an inequality symbol. I'm just going to go ahead and pick the random numbers for you to speed the process along for you. And we'll use the same numbers for all of our charts just so we have consistent values that we can see these differences with. Alright, so go ahead and fill in the inequality symbols in this column here. That would make this true, just to get a quick check on whether you understand your inequality symbols or not. So we should have that this one is less than, this one is less than, this one is greater than, and this one is greater than. So we're going to go through and we're going to make these changes. So as we can see up here, they're going to show the changes kind of in a equation fashion somewhat. Now we're adding -3 to both sides of the inequality. So -2 plus -3. And it's supposed to be less than -2 or 3 plus -3. That would give me -5 and -6. Or sorry, -5 and 0. So we want to see, is the inequality symbol still need to go the same way? And the answer here is yes, -5 is less than 0. So in this case it is preserved. So I want you to go ahead and pause the video and fill that out for the rest of these here. And then go ahead and come down here and answer this question. Looking at the results, is there something that we can notice about this? Alright, so this is what you should have gotten. We should recognize here that all are preserved. So our general statement here that we can make is, if numbers are added or subtracted to both sides, the inequality symbol is preserved. And we can see that it doesn't really matter whether it's positive numbers, negative numbers, whatever we see here. We've added positives, we've subtracted negatives, subtracted positives, we've added negatives. It doesn't really matter which value it is. Our inequality symbol always seems to be preserved. We're going to come over here. We're going to do the same thing with this table. I'm actually going to go ahead and fill in the same quote-unquote random set of numbers. So I'm going to use -2, 4, 3, 1, and 3, 6, 2, -6. That should make the inequality symbols really easy because it's still going to be the same. And we're going to come over here and now we're going to do different operations. In this case, we're actually seeing that our operation is always going to be the same for this particular chart. So go ahead and let's fill this one out, and then go ahead and write your statement about the bottom about what you generally notice about this. Alright, so as I look at these, I've done all of the math for them, and as I start to look at the inequality symbols, now I see that when I've done this one, 2 is greater than -3, so in this particular case, I see that the inequality symbol needs to be reversed. Same thing down here, -4 is greater than -6, -3 is less than -2, and -1 is less than 6. So I can see in all cases my inequality symbols were reversed. So that tells me our general statement down here needs to be that if we multiply both sides by -1, then the inequality symbols are reversed. The inequality symbol reverses. Right. Flip on over to the other side. We got 2 more charts to fill out that are similar to this, so we can explore just a couple more ideas. Alright, as you can see, I've already kind of filled in the chart, again, using the same numbers as we did before. Now we're going to see in this chart that we're going to do some multiplication and division, and we're going to see that we're going to be doing that with some fractions, so we're going to see if that changes anything up. These are all going to be positive numbers, so we're going to see what happens when we multiply or divide by positive fractions or whole numbers. So go ahead and fill out this chart, and let's see what happens. So starting with this, you'll see that I have written all of my divisions. I've taken my divisions and I've written them as multiplications. We know the same thing as multiplying by the reciprocal. So instead of writing division by 2, I've written this as multiplication of the reciprocal, 1/2. Same thing down here, multiplication of the reciprocal, which would be 2 over 1. You can see that's how I went ahead and dealt with that. So as we go through, hopefully you finish this up. And as I've gone through and done all of the multiplications, I've put in the symbols, and we can see in all cases when we multiply by positive numbers that it is preserved. So far we know that when we add or subtract, it doesn't matter positive or negative, that the inequality symbol is preserved. When we multiply or divide by positive numbers, the inequality symbol is preserved. And we know that if we multiply by -1, the inequality symbol is reversed. So we're now looking at the last set. This is the multiplication and divisions of negative numbers. So again, I'm going to just take these negatives or these divisions, I'm going to change them to multiplications of the reciprocal. So this is going to be multiplication of -2. And I'm going to go through and I'm going to fill out my chart. Alright, so as we go through and we look at these, we once again see that all of our signs are changing in our multiplications, and what that seems to result in is that all of our inequality symbols are reversed. So if we start to combine all of the rules that we've seen so far, let's go ahead and look at this lesson summary. It says when both sides of the inequality are added or subtracted to, the inequality symbols stay the same, and so we are preserved. Alright, so adding and subtracting doesn't matter, positive, negative, it's going to preserve the inequality symbol. Alright, then multiplying by the positive numbers, that's coming up here and looking at this chart, we can see that it is going to be preserved. And when both sides of the inequality are multiplied or divided by a negative number, those are going to be our two charts, the multiplication of -1 and this last chart where we had multiplications and divisions by negatives, we see that it's going to be reversed. This is going to be important because we're going to actually start solving inequalities here pretty soon, just like we solve equations. And so we're going to see that we're going to often run into instances where we do multiplications or divisions or additions or subtractions to both sides, and we need to know what happens to the inequality symbol when that happens. Alright, we're going to go back up, have you guys fill out this chart. I'll do the first one as an example with you, and the rest that you'll need to do on your own. So looking at this, basically we're doing exactly what we want to do. We're going to be choosing in this first column an operation that will preserve the inequality symbol. So for instance, I know that if I add 3, that will preserve the inequality symbol. And over here, I'm going to choose an operation that will reverse the inequality symbol, so such as multiplying by -1. And over here, I'm going to write an explanation as to what happens. And our explanation just basically uses what we've just learned. Adding preserves. Multiplying a negative reverses. And then we're going to come over here and we're just going to prove this really quickly with these numbers. 2 plus 3 is less than 5 plus 3. 5 is less than 8. And over here, same idea, multiplying by -1. 2 times -1 is less than 5 times -1. So you're going to be choosing your own operations and choosing your own and then doing your own explanations for these, and you're just going to make something that is true for each of these. Alright, finish that up on your own and then move on to your alone time.